Hi everybody, I'm Johnny Giraldo and this is the video of my presentation, GraphBGS, background subtraction via recovery of graph signal. Then the motivation of this paper is try to avoid data-hungry methods. For example, deep learning, as you know, this kind of methods requires a lot of label information to avoid overfitting. Then in this paper, the basic idea, the main idea is to use the geometrical information that we have in some databases to effectively reduce the number of labels that we need. And we are gonna accomplish this objective using graph signal processing, and we are gonna solve the problem of background subtraction. In background subtraction, the main idea, the main objective is to classify which pixels in the images are moving objects and which pixels are static objects. Then, for example, here we have a video with some cars, and in each frame we have the instance segmentation of the cars. The main idea is to say which of those cars are moving objects and which of those cars are static objects. Then basically we are going to solve this background subtraction problem using semi-supervised learning, and this method of semi-supervised learning is going to be inspired from the graph signal processing community. This is the overview of our algorithm, and here we have some videos. We are gonna we are gonna segment some instances in the video. Here we have a cascade mask RCNN, but we can have another segmentation algorithms, for example, superpixels or semantic segmentation as well. And also we have here the background of the video. After that, we are gonna make a feature extraction. We are gonna use the median filter information. We are gonna use also intensity information. We are gonna use texture information, and with those features we are gonna construct a graph in which each node in the graph is some instance in the video. Can be a superpixel. A node can be also a mask from the mask RCNN and so on. And we are gonna construct a graph signal in the graph, and this graph signal tell us if that node is a static object or a moving object. And after that, we are gonna make graph sampling, but this graph sampling should take into account that the unseen videos. That means that if we are gonna segment this video, we cannot sample the nodes that correspond to that video. Then basically this is the idea of graph sampling, and after that we are gonna use a semi-supervised learning algorithm that in this case is inspired by the Sobolev norms of graph signals. At the end we are gonna have our map or output of moving objects. With this image we can understand a little bit better our algorithm. Then basically here we have some instances, some cars, and we are gonna map those instances to the graph, and we are gonna say, okay, this is a moving object. Then if that is the case, we are gonna have a green node, but if we have a static object, we are gonna have a blue node. Then after that we are gonna sample the graph signal. That means that we are not gonna have all the labels of the entire database, and the idea of the semi-supervised learning algorithm is to reconstruct the whole graph signal. That means that we are gonna we are gonna put all colors in this graph. Then that's basically the idea of the semi-supervised learning algorithm. We are gonna extract motion features, texture, intensity, background features, and we are gonna construct the graph via k-nearest neighborhood with k equal 30. Here we have some visual results of our method, and we have some numerical results. We can see that our method is better than several methods. Even these are deep learning methods. Then this is the visual results and the numerical results. Finally, this is the first work that use graph signal processing to solve the background subtraction problem. Our algorithm is composed of a cascade mask CNN. We have a median filter, feature extraction, a graph construction, and we are using the solver of graph signals to solve the problem of semi-supervised learning. For future work, we want to explore a little bit more other ideas of graph signal processing. We want to make an inductive framework, and we also want to explore active semi-supervised learning in this problem. Thank you. Let me know if you have any questions.